what we're going to do. You've got the table. Oh, I don't know. Let's just say I'm going to create a table with this pen and say, well, we need a different color first. No, we can't ask questions right now. I got to move forward for now. Hold that thought. Write your question down, and I will answer it at the end of class if you'd like. So let's say this. Let's say that I've got this table here, guys. Okay, not the best table, not the prettiest table, but it is a table. And I've got my X and my Y, and let's say that I've got these values here. 1, 2, 3, 4. Cool stuff. And let's say that I've got the values negative 4, negative 3, negative 2, negative 1. All right, so as I go along, the first question is there a relationship here? Do I see a relationship? Yeah, it seems like I might have one. I see that as this moves up, 1, 2, 3, 4, this moves down, negative 4, negative, or this also moves up too, negative 4, negative 3, negative 2, negative 1. So let's see. In fact, if I took x, it looks like if I took x and subtracted 5 from it, take x and subtract 5, I'm going to get the value y. Because negative 4,
Isn't that writing a function? Yes.
Negative 1 minus,
X minus 5.
give me a second here, x minus 5, that doesn't make sense. Subtract 5 from, let's do this again. Let's do this again, guys. Let's take, let me think here. Yeah, 1 minus 5. I wrote the y value in the x. I'm really taking 1, subtracting 5, and I should get y, negative 4. And then if I took the x value, 3, and subtract 5 from it, again, I'm just proving my fact that, yeah, I've got a function here. So I should get negative 2. Negative 2. All right? So yes, there's a relationship. And the way I would write this function is,
Right there. X minus 5.
the way I'd write this is that y equals x minus 5. Box it up. Let's move on from here. So that is how you would write a function, or you would use a table to write an equation. That's just using a table to write a basic equation. But let's move forward and actually identify independent and dependent variables. I'm going to rewrite that. It was a little bit sloppy. Okay, so let's go ahead and try to identify a couple of these here. So let's say this, guys. I'm given this function, and it's a unique function. It's called f of x. So let's say I've got this function, and the way it looks notation-wise is f of x. And the way that I would say this is f of x. It sounds like f of x. But that's how, this is what the symbol actually looks like, f of x. So this is my unique function, and it's read, as I said, f of x. And let me read through a problem here, and we'll try to, actually, before I even do that, let me just go over some real cool facts about this. F of x it's my y value. If I were to say, hey, f of x equals x, then whatever value I'm given for x, I'm going to plug it in right here for x. Right? I know that sounds a little bit confusing, but let me go through some of these, just create a table with you guys, and it will make more sense. And what I want to say here is, on the left here, I'm going to have my independent variable. And I stopped spelling it because I ran out of room, but independent's on the left, and dependent is on the right. Thanks, buddy. Okay, so now the next thing that I'm going to do is say, hey, my independent variable is also my x value. Whenever we graph independent variables, we always put it on the what axis, guys? The x-axis. Dependent variables is all, it's going to be my y values. All right, we'll move down from here. And another way to think of my x value is my domain. We've already gone over that, but domain, which means my y value would be my range. Get some more room here. This is also my x value, my independent variable is also what I'd call my input, whatever I put into the equation, whether it's time or speed. And let's look at, this would be my output. So guys, also an independent value is also my x value for ordered pairs, where the dependent is the y value. And here's the last point that I want to get at. Since the y value, since x is the y value, when we talk about the unique function of f of x, well, x is also the independent, but f of x is the dependent variable. And a way of thinking about this, guys, is that f of x is equivalent to y. When you say f of x, you're really talking about y. These two guys are the same thing. So the big take-home message here is that the dependent variable depends on the independent variable. All of these values over here on the right, and you know what? This might help you out, Trevor. If I did something like this, is to say, hey, all of the dependent variables right here to the right in green are y, but they depend on any of the independent variables. These are just different ways of saying independent. These are different ways of saying dependent. These are different ways of saying x, while these are different ways of saying y. So a dependent variable depends on an independent variable. What's up?
Would the f of y be x?
We don't talk about the f of y. No.
So is f...
We're not talking about that today, okay? F of x is y.
Is f of x a function?
Huh? Is f of x a function? If f of x is a function, it depends. It's a unique function. I see what you're saying. Yeah, it's a unique way. It is. Okay? All right, guys, let's move forward. Hey there, kiddo. What's up?
Doesn't she deserve some candy?
She does, but we got to keep rolling with notes, guys. Okay. Guys, let's move forward from here. So let's actually look at, get my mouse up on screen. Huh? Let's look at a way of writing some functions here. I think it'll make more sense. So I'm going to read through the following problem and maybe write it out, type it on the board here. So let's say that a gardener charges $5 per square foot for yard maintenance. So let's find out what the independent and dependent variables are here. I think you'll be okay. Hey guys, y'all want to stay in here? You got to be quiet and work. So let's say, hey, these are going to be what I call my independent my dependent variables. So let's go through and find out which is which. So a gardener charges $5 per square foot for yard maintenance. Well, my independent variable, does anybody have a guess here what it could be? Ian, what do you think the independent variables in this? The number of square feet. Absolutely, yeah. Square feet. So number of square feet. Is it feet or yards? Number of square yards.
You said square feet.
For yard maintenance, thank you. So it's for yard. So it's number of square yard feet. You got it, Ian. So the dependent variable, Cody, I would like you and, let me see here. I'm going to have you and Jacob switch spots, bud. Go. Move it. Okay, so the dependent variable is, actually, Cody, stay where you're at. Jacob Malandano and Jacob Hill switch. Thank you. So the dependent variable, guys, the dependent variable is, we're going to call this the cost of yard maintenance, okay? We'll just call this the cost. So now how can we write a function from this? Well, let's see. Let's say that my function, I'm going to create an extra little box here. Let's go back to green. So my function, I'm going to say f of x first. I'm going to say f of x. So my dependent variable equals f of x, the cost. Don't forget the parentheses around the x here. So the f of x, it has the cost, well, $5 per square yard or per square foot. So it has the equal 5. Per is a good term for Q word for multiplication. Dylan, good call, buddy.
Why do you keep on using f of x? Is it like applied to everything?
Well, hey, look at this. Look at this. I could write it another way. I could write this another way. Ready? Look up there.
X stands for y.
Look at this. I could say, hey, y equals 5x, right? But I say f of x because it's a unique function. Okay? It's a unique function. What's up, bud?
It says charges $5 per square foot. Can you do $5 slash FT
Did you say this again?
like,
Oh, I see what you're saying. I
Yeah.
totally see what you're saying because it's, yeah, a slash for what?
so I mean like no, I mean like
Make it shorter.
to make the text shorter on top.
What are you saying?
Foot square.
Like put square it. You could
I don't know where you're pointing to, buddy.
make it easy.
What are you talking about, Jacob?
Text up top.
The text up here.
Yeah.
No.
What's the
You could
question?
Shorten that by just having so
A slash? Yeah, actually you could, and that's a great question because the other day I was talking about symbols, and that is a great symbol to use. But in a word problem, you're probably not going to get that slash, are you? Right? But down here I could say cost per square foot, right? Cost per square right here, right? Okay. What's up?
Well, if the y is a dependent variable, then why do we put f of x on the
Well, I just created, you know what, that's a great question. This is what I should totally do for you guys too. This line, it went a little too far. We don't need this line. So this isn't really divided. This bottom section is including the whole thing. I know, you guys are all right. I think y'all, that's a good question, Peyton. Thank you. Okay, so let's move on from here. That's writing functions based off of problems. So let's actually, I don't know, let's evaluate functions now, guys. Okay, I got to get through 2 more with you, so I need y'all focused. Evaluating functions. So we're going to take a look at this problem here, all right? So for f of x equaling 2x, I want you to find Find f of x when x equals 10 and when x equals 12.5. Sounds like a lot, guys, but all you got to really do is parse this question. Parse means to separate, split up, break up, right? So all I want to do is parse this. The first thing all it's giving me is the function of f of x equals this value here. You can say, hey, it equals this. So what I want you to do is find f of x. Find, hey, this is the same thing as up here. It's just saying find this. Find this right here when x equals these two values. So all you're going to do is substitute x back into f of x for that as well. You're going to put in a both. So it's saying when f of x equals 10, I'll put it here. When f of x or f of 10 would equal, when I plug or substitute 10 into x, it equals 2 times 10.
But that'd be fun.
2 times 10 is 20.
So now I want you guys to take a minute, maybe 10 seconds or so, and find f of x when x equals 12.5. Everybody, go for this. I don't want to hear it. I want y'all to work it. Did I say I want you to yell without being like a madman? Did I say I want you to be a wild dude and start hollering and hooting?
Me?
Yes. We're not on 6th Street. It's not a Friday night.
No,
We're not at a football game. We're not at the Westlake football game playing against Gangster. No, we are here in that spots. Raise our hand after we say. We're calm, cool, and collected. With Coach, no, Mr. Gillespie. Yes, ma'am. Yes, you may. Please tell me how. And no, you may not. Tell me. You have got to. No, I know I'd love you to, but I'm really low on time. What's the answer? Just yell it. 25, absolutely. It's 25. So what she said is this, guys. Where did I put that pin at? That's not good. No, oh, there we go. So this is what she said. She said this. She said when f of x equals 12.5, well, that equals 2 times 12.5. And that equals f of 12.5 equals 25. Because 2 times 12.5 equals 25. Okay, going down to our last one here. We got our last one where you are going to, hey guys, you're going to get this in the book. It's going to kind of sound tricky, but look, it's not to trick you. We've been dealing with f of x. The book's going to do something like this. It's going to change the variable f here and say g. And it's going to just give you a different letter. These are the same thing. It's not a trick because variables can be what? Many letters. They can be different letters. And they might not even say x. They might say t. They might say g of t or g of y. And yes, they're always the y value. And what it's going to say here is it's not going to say solve for when x equals. It's going to say solve for when t equals. Or if they said b of y, I don't know, b of y. It's going to say solve for when y equals. And it's going to give you values to plug into the y values, okay? Cool. They're all the same thing. Now I'm moving on to the last problem, so hold your questions because this is mucho important that we get this.
No, Jacob. Hey, Jacob. Hello. Jacob. How you doing? Sam wants to go to school. Yeah.
We're going to say Jacob has already spent $36 on tickets for German lessons. There are 3 more lessons remaining, and they cost $4.50 each. So what I want you to do is, I'm going to spread this out some so we can see it. Write a function rule to describe the total amount of money, and I'll do the $sign there, the total amount of money that Jacob might spend on tickets for lessons. I'll just stop at tickets. What's that? It's okay. Yeah, I'm a math teacher. Anywho, and then I want you to give a reasonable domain and range for the function. Give a domain. Hey Carter, where's your focus, dude? Cool stuff. All right, guys, so here's the function that we're going to write. Let's talk about this problem. We got to parse it just a little bit and just say, hey, I want to solve for a value. Hey, dude, I want to solve for something. Well, what's my dependent variable? Fx or y, right? Either one. So I'll say my dependent, I'm going to call it f of x right now. It could be y. It equals my independent information. Well, how much money? I already know that Jacob spent $36. So he's already out 36 bones.
I got it.
36. But he can also add a certain amount, 4.5, because that's the cost of tickets, times the number of tickets he or sessions that he purchases. So that would be $4.50 times X. And we don't know how many sessions. Maybe he doesn't like the German teacher. Maybe the German teacher smells, or maybe the German teacher is really good, or he likes the chocolate that they have inside the session lesson, because Germans make the best chocolate. And so what we're saying here, guys, is that this is the function I'm writing. So now my domain and range would be this. Let's solve for just one of my domain. Let me go here. Excuse me for a second. My domain here, guys, my domain can only be a certain number. They are fixed, and that is 0, 1, 2, or 3. These are the number of times that he goes to see his teacher for the sessions. Well, domain is also the independent variable. So what I'm saying here is that when f of x is 0, this equation is going to be, well, yes, it's going to be 450 times 0 plus 36. So my range, I'm going to write that in a different color, is going to be, well, for this one, it's going to be 36, because 450 times 0 is 0 plus 36. Well, what if when f of x is 1? When f of x is 1, I have 450 times 1 plus 36. Well, 450 times 1 is 450 plus 36. It would be $40.50, or 40.50, right? 40.5. Okay? So f of 2, the way that you would solve for the rest of these is to say, hey, f of 2 is, and f of 3 is, and these are the values that you can have. 4.5 times 2 plus 36, or 4.5 times 3 plus 36. Hey, guys, listen up. Trevor, this answers your last question that you had, your first question of the day. Trevor said, hey, when I've got a graph here, and I have discrete points, what does that really mean compared to when I have a graph? I'm going to make two graphs. That's continuous. Well, discrete means you have distinct points on the graph. You have discrete points. Whereas continuous means you either have a straight line that's continuing, or you could have also a curved line as well. That's all that's continuous versus discrete.
And is that mean what if you have it going on over time?
It could, or it could end after a certain amount.
Okay.
And yes.
What if you have points on but it never stops? If there's a line and then
Time out. If I have a stopwatch and I'm timing you run, and I'm getting your splits over time, or your speed over time, I could have a continuous time. It can stop. Does that make sense? It can have a stop time. And now, what's your question, Jacob?
what if you have distinct points on a continuous graph?
You can't.
So what if you have like a line and then you have points like
Well, you can't have two. You either have a discrete graph or you have a continuous graph. So either the points are connected or they're disconnected. They're distinct. Okay. Good question. Hey, have a good one, dude. Take care. Hey, Cade, you had a question earlier. I didn't get to you. What was it?